Good morning, students. Today we are going to solve question number 16 of exercise 10.2. Here the question is, find the position vector of the midpoint of the vector joining the points point P whose coordinates are 2, 3, 4 and the points Q whose coordinates are 4, 1, minus 2. So my point ani pireba. Sige position vector of the midpoint puthokdoiniko akhona mamangi class da position vector of any point aduga point sina atoba given point ani se internally or externally ratio da kakpagi formula tamgre ko. Question number 16 gi solution puthose. First write the coordinates of point P. Coordinates of point P is 2, 3, 4 and coordinates of point Q is 4, 1 and minus 2. Let R be the midpoint of the point Q, PQ. Midpoint PQ have a line sige midpoint se akhona point R se na lower se, then the position vector of R denoted by OR vector is equal to OP vector plus OQ vector divided by 2. And so position vector of OP, x coordinate 2ik plus y coordinate 3ck plus 4kk plus and OQ vector. Position vector of Q will be 4ik plus 1jk minus 2kk divided by 2. Habadi R sina PQ ki midpoint oitardi R divides PQ in the ratio 1:1. 1:1 have ratio sidamana kakraneba duna nangi ratio se m:n se 1:1 where the 1 plus 1 se 2 tarani ko ani se plus taurasi. Find the sum of these two vectors. 2ik plus 4j 3j plus 1k and 4k minus 2k. 2 plus 4 is equal to 6i, 3 plus j is equal to 4j and the 4k minus 2k is 2 times of k. Then divide these components by these two. We get 3i, 2j, k is the position vector of the point R, which is the midpoint of kanagi midpoint oiba midpoint of the line segment PQ. Now next question is question number 17. So that the points point A, B and C with the position vectors A vector 3i minus 4j minus 4k, B vector 2i minus j plus k and C vector I minus 3j minus k 5k respectively form the vertices of a right angle triangle. Step piriba point ahum pireko. There are 3 points with position vector A vector, B vector and C vector. Then we have to show that this point A, B, C are the vertices of a right triangle. Right triangle amagi vertex ni haina koina show tawdoini ko. Question number 17. Mana vector use tawdoini. Here we have OA vector. Position vector of A is equal to position vector of A is equal to 3i minus 4j minus k and position vector of B is equal to 2i minus j plus k and position vector of C is equal to I minus 3j minus k. And now find AB vector. Kung AB vector ay sa kaino yingsiko. First find AB vector. AB vector se ano putoksiko triangle lami draw a triangle ABC and these vertices are represented by point A, point B and the point C. Then find this side AB. Then find BC and find CA vector. Now AB vector is equal to position vector of B minus position vector of A. Write position vector of B and the position vector of A. Then find the difference of these two vectors. 2 minus 3 is equal to minus I minus 1 minus plus minus 1 plus 4 is equal to 3j and the 1 minus plus and 1 plus 4 is equal to 5k. Then find BC vector which is equal to OC vector minus OB vector. Sina initial ni terminal ni ko. Terminal minus initial point. OC vector ito, OB vector ito, subtract or record 1 minus 2 is equal to minus I minus 3 minus plus and minus 2j minus 5 plus minus 6 times of k. Then find CA vector, position vector of A minus position vector of C, which is equal to, write the position vector of A and position vector of C and find the difference of these two vectors. 3 minus 1 is equal to 2I cap minus 4 minus minus plus minus j cap and minus 4 minus minus plus minus 4 plus 5 is equal to k cap. So main taragi AB vector, BC vector, CA vector putoy ko. Then find the length of each sides. Find AB side, BC side and the CA side. Kung side and whole vector dagi side hot ke hai tardi, find the magnitude of AB vector, magnitude of BC vector and magnitude of CA vector. Magnitude of AB vector is equal to root over minus 1 square plus 3 square plus 5 square. Minus 1 is x component, 3 is y component and 5 is z component. Minus 1 square is 1, 3 square is 9, 5 square is equal to 25 and their sum is equal to 35. Then find BC vector whose components are minus 1 square, minus 2 square, minus 6 square and their sum is 41. Then find CA magnitude equals to 4 plus 1 plus 1 is equal to root over 6. Sigi manung the kwai sang was 41 ni ko adun atenba ani lowers. Atenba ani sa AB have a siga, CA have a siga sinalisoy bani ko. Now AB vector square plus CA vector whole square is equal to 35 plus 6 is equal to 41. Then this 41 can be expressed as magnitude of BC whole square. And AB square plus CA square is equal to BC square, which is the Pythagoras theorem of a triangle. Triangle amagi Pythagoras theorem ne. Triangle ama the Pythagoras theorem yataragadi triangle do kai kaurani. Right angle triangle kauduni ko. Right angle triangle or therefore triangle ABC is a right angle triangle and right angle at kai the right angle or any A do or any but BC is the hypotenuse and the AB and the CE are the remaining two sides of the triangle ABC. And so this triangle ABC is a right angle triangle and a right angle at A the right angle oiba right triangle amani. Therefore ABC are the vertices of a right triangle. Any right triangle amagi vertices ngakta oireba ko. Now we are going to learn about product of two vectors. Product of two vectors, the types ani lay number 1 scalar or dot product of two vectors and second one is vector or cross product of two vectors. Vector product sida makal ani laire scalar product or dot product haiba ma atopa mana vector or cross product kawi ko. Now first one is scalar or dot product of two vectors. Scalar product se ana define tarasi. The scalar product of two non-zero vectors A vector and B vector denoted by A vector dot B is defined as A vector dot B is equal to magnitude of A magnitude of B multiplied by cos theta, where theta is the angle between A and the B and theta lies in between 0 and pi. 0 and pi means theta lies in between 0 and 180 degrees. Straight line amagi manungda leiba oigadaba ko. Sida koina theta haibam lor. Theta se kana gi angle no here. Theta is the angle between the given two vectors, vectors A vector and vector B vector. And A vector dot B vector is defined as magnitude of A magnitude of B multiplied by cos theta. Magnitude of A vector A gi asangba ko, magnitude of B vector B gi asangba, and cos theta cos value, where theta is the angle between A vector and B vector. Sinanangi scalar product defined tawre. If either A vector equals to 0 vector or B vector equals to 0, then A vector dot B vector will be equal to 0. A ga B ga gi marak sida ama 0 chatlaga di A dot B se kai tagrani 0 tarani ko. Koina scalar product haire ko. Then observations. Observations number 1, A vector dot B vector is a real number. A vector dot B vector is a real number means scalar neighbor. Magnitude of A is a scalar, magnitude of B is scalar, and cos theta is also a scalar. So the product of the scalar is scalar. Scalar means real number, any real number amoy bayay. Number 2, A vector dot B vector equals to 0 if and only if A vector is perpendicular to B vector. If and only if A vector is perpendicular means if A vector dot B equals to 0, which implies that A vector is perpendicular to B vector, or if A vector is perpendicular to B vector, then their scalar product will be equal to 0. Chida koina part kya laire ani laire ko. For first part ahan bagi part saying if A vector is perpendicular to B vector, A ga B ga perpendicular oiragadi then theta will be equal to 90 degree, and cos 90 degree is 0, and therefore a dot b will be equal to 0. If a dot b is equal to 0, a ga b ga gi dot product at 0 itardi, then write the definition of a vector dot b vector, which is equal to magnitude of a magnitude of b cos theta equals to 0. Magnitude of a, magnitude of b, and cos theta. If a vector, b vectors, then non-zero vectors or tardi, cos theta is 0 chatni buka, which implies that theta will be equal to 90. Cos na 0 chat pasa karam kanda tai hai tardi, theta ki value sina 90 degree or kanda. Next observation number 3, if a vector is parallel to b vector, then theta equals to 0 or theta is equal to pi oina phangiko. Habadi a ga b ga parallel is a case ani do if a and b have the same direction, then theta will be equal to 0. A ga b ga se same direction already theta se 0 chatkani. If a and the b are in opposite direction, then theta will be equal to pi. A ga b ga parallel oibadana theta se 0 taba ko, a ga b ga opposite oibagana theta se kai oiba pi oineba, and therefore a dot b will be equal to magnitude of a into magnitude of b, since cos 0 is equal to 1. But in second case, a dot b will be equal to minus magnitude of a magnitude of b, since cos pi is equal to minus 1. Sina same direction, sina opposite direction or kind. In particular, a dot a is equal to magnitude of a multiplied by cos 0. Magnitude of a into magnitude of a is equal to magnitude of a whole square. So the cos 0 lies se kaigino hai tardi a same vectors neba. Same vectors hai tardi angle se 0 tani ko aduna cos 0 ki value di 1 tar. So a dot a will be equal to magnitude of a whole square. For Roman number 4. For mutually perpendicular unit vectors I cap, j cap, and k cap, we have I dot I, j dot j, k dot k is equal to 1. I dot I se hold in a I dot I, from the definition, I dot I will be equal to magnitude of I multiplied by cos of 0. Since magnitude of I is 1, magnitude of I is 1, and cos of 0 is equal to 1. So it will be equal to 1. Similarly, j dot j and k dot k will be equal to 1. I dot I, the magnitude of I and cos 0 ibadauna j dot j the magnitude of j cos 0 irani ko aduna sigi I j k have a mutually perpendicular unit vectors neighbor means angle between is one of the two vectors is 90 degree. I su j su k su moise 90 degree the loina ek tawra leiba vectors ngatani ko aduna sigi se 1 tagrani. Since I vector is perpendicular to j vector is perpendicular to k, and the k vector is perpendicular to I, therefore I dot j dot k, and k dot I will be equal to 0, since they are mutually perpendicular unit vectors. Next observation number 5. The angle between the two non-zero vectors a vector and b vector is given by the formula cos theta is equal to a dot b divided by magnitude of a and magnitude of b. Sikai daila ino hai taragadi a dot b is equal to kaigamanagi magnitude of a magnitude of b multiplied by cos theta sigamanagi ko, and find this cos theta from this equation. So cos theta is given by a dot b divided by magnitude of a into magnitude of b. Nana vector sani gi angle puthokninga di sigi formula se pantare ko. Next observation number 6. The scalar product is commutative. Scalar product is commutative, that is a dot b is equal to b dot a. This law is known as commutative law. Next, two important properties of scalar product. Scalar product ki tongan important properties ani leko. Property number 1, distributivity of scalar product over addition. Let a vector, b vector, and c vector be any three vectors, then a vector dot b vector plus c vector will be equal to a vector dot b vector plus c vector is equal to a vector dot b plus a vector dot c. And this law is known distributive law. Distributive law kawiko. Next property number 2, let a vector be any two vectors and lambda be a scalar. A ga b ga sina any vector sani ore, lambda sina any scalar ore ko. Then lambda a vector dot b is equal to lambda a vector dot b or a vector dot lambda b vector. Habdi a gi multiple the lambda layer. Sidana b gi multiple the lambda layer. Lambda multiple of a vector dot b. A ga b ga dang scalar product logani lambda se yaw. Next topic is scalar product of two vectors in component form. Scalar product of two vectors in component form. Mamang the igiba formula duna magnitude express to handagna component form. The component form means ijk the express to waseko. Let a vectors equal to a1ik plus a2jk plus a3k and b vector equals to b1ik plus b2jk plus b3k. Be any two vectors, then a vector dot b vector is equal to a1ik plus a2jk plus a3k dot b1ik plus b2jk plus b3k. This is equal to, first find the scalar product of a1ik with the second expression b1ik plus b2jk plus b3k. Then write plus second term igada a2j. Sigi a2j ga kanaga scalar product logani b1ik plus b2jk plus b3k. Then find scalar product of a3k cap, third term of the first expression with the second expression b1ik plus b2jk plus b3k cap. Then apply dot product. A1 b1 real number I dot I, a1n b2 I dot j, a1 b3 I dot k. I dot k si ireko. Next a2 b1 j dot I, a2 b2 j dot j, a2 b3 j dot j si itoeko. Last a3 b1 k dot I, b3 a3 b2 k dot j, a3 b3 k dot k si itoeko. Masagi observation da ijk na mutually perpendicular unit vectors to itardi I dot I is equal to 1, j dot j, I dot k, j dot I, j dot k, k dot I, k dot j siloin 0 chatkrani bako. Nang lem hodori se I dot I ne, j dot j ne, k dot k lem hore. So the remaining terms are a1 b1 plus a2 b2 plus a3 b3. Scalar product of two vectors in terms of their component haitardi kaigamanani. Find the sum of product of corresponding component. Corresponding component means find the product of first component x component, find the product of y component, and find the product of z component and find their sum. Si hana lang puthokani. A1 ga b1 ga into taurani, a2 ga b2 ga into taurani, a3 ga b3 ga into taurani, tuga sum puthokadabako. Tuna nangi scalar product of two vectors in terms of their component. Component means ijk the express taw taragadi x ga into tawani, y ga into tawani, z ga into tawani, tuga marakta plus sign thamgani. An example yingsi. Example ka, there are two vectors a vector and b vector whose components are 2ik plus 3jk minus k. B vector equals to ij minus k plus 3k. So a dot b vector will be equal to, find the sum of corresponding components. 2 into 1, 3 into minus 1 into 3. 2 into 1 is 2, 3 into minus 1 is minus 3, minus 1 into 3 is equal to minus 3. Minus 3 is minus 6, and 2 minus 6 is equal to minus 4. Minus 4 is a scalar, and so a dot b is equal to minus 4. Sina nangi vector se component form the p wagi ka. Now we are going to learn about projection of a vector on a line. vector amana atopa line amada directed line amada leba projection ni ko. Suppose a vector AB vector makes an angle theta with a given directed line segment L in the anti-clockwise direction. Then the projection of AB vector on L is a vector P vector. P vector means AC vector with magnitude of AB into cos theta. Koina sigi line L se given directed line ne sigi mathak sida koina vector ama sigi mong si thamme ko stand tore AB vector hare. AB vector sigi terminal se terminal point of AB vectors dagi perpendicular mayo. Draw a perpendicular BC which is perpendicular to this line L drawn from the terminal point of AB vector CA ko. Then this theta is the angle made by this AB vector with this directed line L in anti-clockwise direction. Anti-clockwise the low ganisi angle se ko. When theta formed the red, then we found AC vector. Then this AC vector is represented by this small letter P vector. So the projection of AB vector on this line L is this P vector. This P vector is niko and magi magnitude se. Magnitude means the length of this P vector AC is equal to kaigamanani AB multiplied by cos theta. AB multiplied by cos theta means ABC is a right angle triangle, and so AC is the adjacent side of this angle theta. Theta sigi adjacent side neba ko. Duna nang na sida ko si iba kanda AC divided by AB haina phang neba, and so this AC is given by AB into cos theta. Thi cos theta silakani, but this cos theta is positive tarakpa yai negative tarakpa yai ko aduna koina modulus hainam hapselani kaigino hairadi magnitude haibasidi always positive quantity oigadamne. The projection of AB vector on the line L is represented by this AC vector, and the length of this AC vector is given by AB vector divided multiplied by magnitude of cos theta. Chiki formula se khang tare ko. Next, projection of A vector, say A vector on B vector. Nasaina vector amana line amada project tau. Handagna vector amada atopa vector amada project tau bako. Projection of a vector on B vector. So this B vector should be the base vector with areko. Let OA vector represents A vector and this OB vector represents small b vector. We draw AP, which is perpendicular to OB, and angle AOB is equal to theta. Theta is the angle vector. Projection se makal ani suiko scalar projection haiba maga kaigalai koina projection se makal ani suiko mamangdana ngasai so high grade scalar projection of A vector on B vector haiba ma atopa mana projection vector of A vector on B vector. Sigi topic se important ni ko. Now scalar projection of A vector on B vector is the scalar OP. O dagina P bagi distance scalar projection kaweba. OP hadi khangani ko P is the point drawn from the terminal point of this A vector. Magi A vector sigi terminal point sidagi OB haiba vectors the perpendicular oina yegla iba. Chigi point P se sigi koina AP se haire ko. In OP o dagina P ki distance scalar projection of A vector on B vector kawe. Then this OP is the adjacent side of this angle theta. Angle theta sigi adjacent side type. This OP is represented by magnitude of OA vector into cos theta. Sina represent of where since this OA vector is equal to magnitude of A and cos theta is represented by A dot B divided by magnitude of A and the magnitude of B by using the definition of scalar product of two vectors. Scalar product of two vectors ke definition do use tawraga koina cos theta gi mahuta A dot B divided by magnitude of A magnitude of B na sinbeare ko cancelling magnitude of A we have A dot B divided by magnitude of B si phanganiba, which is the scalar projection of A vector on B vector. Si phange ko base to na magnitude of B na divide tawrakadaba. Now we are going to find projection vector of A vector on B vector. Projection vector hairadi vector on E tareba. This OP vector, and since OP cap is equal to OP vector divided by magnitude of OP. Any vector amade ek tauba unit cap sa kaiga manai hai tardi magi vector to the magnitude na divide tauba manai. So this OP vector is represented by magnitude of OP vector into OP cap. Figure the ko OP have kana ek taraga lay B vector have ek taraga lay ko, and so this OP vector is same as this B cap. And OP vector means scalar projection ko, scalar projection of A vector on B vector, and so it is represented by A dot B divided by magnitude of B and B cap. And this A dot B divided by magnitude of B and B cap. B cap is given by B vector divided by magnitude of B, since A dot B is a scalar. And magnitude of B into magnitude of B is magnitude of B whole square. Scalar multiplied by this B vector, and so scalar projection of A vector on B vector is a scalar, but projection vector of A vector on B vector is a vector. See this scalar ngatane buko. See the kaina multiply togadaba B vector sina multiply togadab. For today, let's end here.